Okay, it's been a while since I posted a video. I've been just crazy mad trying to get this thing done. Plus, over the summer, there's just too many other things to do. Um, but my goal is to get this done by the end of the year, and I'm almost 95% done. The only thing I got to do is make the arm here that extends out, that holds the spindle in place. I have to make that and the mount for the motor on the back. I'm using a flex shaft rotary tool. Um, that's what I use on my current big mill, and it seems to work pretty good. It's not the most powerful thing, but it can always be upgraded later. Um, but I guess for my first video, it's come a long way. It was basically just rough, welded up. I don't even know if I had it machined yet. I have to go back and look at that video. But the control cabinet's pretty much done. Uh, what I'm using for that is it's all made out of sheet aluminum, and it's got a 10-inch touchscreen in it, and all the controls are inside it. On the side here, there's three USB ports. There's two switches here. One is for I'm going to make a adapter for a laser so I could basically pull the spindle off and then put a laser in its place and then plug it into the side. So this turns the power on and off the laser, and then this switches the signal from the control board to the solid state relay to turn the spindle on and off, and if I flip it up here, it'll send that signal out to the laser power supply. And then this is where you plug in the spindle motor, and this is just the power in and the main power switch on the bottom. And there's an e-stop switch here on the front. Here's a mistake. I put the e-stop here and I realized forgot that the plugs here for the touch screen come right out here, and there was no space for it, so I moved it down there. I have to put a little plug in that. Over here on this side, there's the jacks here for the limit switches and each of the stepper motors. And then up here on top is where the laser will plug in. And to access the inside, this panel here lifts up, but I have to unplug the touch screen. The cord is just a little bit too short. So that unplugs and flips up. So that's the back side. And inside here, let me zoom in a little bit. Okay. And then this panel just lifts up and out. And it just pops right off. And this is the main power in down here. There's a filter for the spindle motor. I didn't want any noise to go back through the line or be transmitted into the power supply or anything else, but I might not need it, but I put it there just in case. This is basically the power block for the 110 volt supply. I got a 24 volt DC power supply over here. This is a solid state relay to turn the spindle on and off. These are the laser switches. I'm using a Raspberry Pi with a Protoneer hat. This hat I just love. It's the most, I don't know, clean setup I've seen. It basically has Gerbil. Basically this hat has an Arduino built into it with Gerbil, and then the Raspberry Pi is a computer that sends the G code to the Gerbil on the Arduino, and then it has the stepper drivers here that just plug right in. All these connectors can be unplugged, and then you can pull the whole unit out if you want to fix something, or it's really nice. Everything's on DIN rails, I got a 3D printer. Basically, my excuse to buy one. I figured, I need DIN rail mounts. I need a printer. So I finally got into that. Over here is these are buck converters. These will take the 24 volt power volts from the power supply and reduces them down to 5 volts, and then so one of these is for the Raspberry, powers the Raspberry Pi. The other one here powers just touch screen up here on top, and then the one on the very end here is 12 volts, and basically that runs the fans. That's all that does. I'll go over here to the mill and show that. Over here, I can't remember what I had on the last video, but it uses 6-inch C channel. On the bottom here you can see it's just a piece of 6-inch welded with, there's plates welded on the bottom for feet. The column here is 4-inch channel. So yeah, that's 4-inch channel, and then it has 1/2-inch plates welded on the bottom of that, and then all the linear, everything is on linear rails. I don't know if you tilt it up here a little bit. It's really not that heavy, but these are 15mm linear rails. The screws are what you would see in a 3D printer with the anti-backlash nuts on them. And these are NEMA 17 stepper motors. And let me see here. On the Z, I don't have this tight, so if you see it wobbling, I don't have it tight yet. And on the Z here I have 9mm linear rails, and the saddle here and the table and the Z head plate are all T6061 aluminum. It's basically, I made this around what I had for scraps basically. So let me put this back together here and I'll fire it up and give a quick demo. See if I can get it without any glare on it. And this has the image that that you can download from the Protoneer has everything pretty much pre-installed and configured for you, so it's a really easy plug and play. So it has BCNC, which is what I'm using. There's Universal G-Code Sender, there's a Chili Pepper, Laser Web 3 server, I'm not sure what that is. Let me see. I think that's about it. So, sometimes I can't get that the first time. Sometimes I sit there and touch it multiple times, but this time it worked. Let's see. So I'll do a homing operation here. Go up here where it says home, you hit home. I'll zoom out. does a rough home, then it backs off and goes in slower and hits the home switch a second time, and then it backs off 5 millimeters. You can set that to whatever you want in the Gerbil settings. So I will run a quick program here. Well, actually, I'll show how it jog in here. Let me jog it around. Alright, I'll zero out the axes. Axis? I don't know how you say that. Axes. You can change the view here to X, Y. Let me see here. I will load a file. Let's see here. Open. I got a test file here. I did in Fusion. Sometimes the only thing is I don't know how to use the touch screen to zoom, so I still have a mouse plugged in. So I want to zoom in and out here. I'm sure there's a way to do it. Let's see. So I am out of the boundary box, so I have to jog it around a little bit here. Let me go back to control. Let me see. I can't do that left-handed. Alright, zero these out. Zero. Alright, now I'm within the boundary. I don't know if you can see that or not. I'll zoom in. It's probably a terrible video. I'm sorry. There's glare from that light. Alright, so that basically there's a circle that's bored down through, and then over here there's a hex shape. There's a spiral path downwards, and it machines out the hex. Then it goes over here to the side. This is adaptive clearing here, and then it does a final pass on the outside. So I'll go back here to the ISO view. Alright, so we got. Let's see. Up here and hit start. Crank the speed up. This is at, I don't know what feed rate this is. It's like 500 or 600. It's actually sort of quiet. So this is the adaptive clearing part. Now it's on the outside perimeter. Okay, and hopefully in the next video I'll show it making some chips. Thanks for watching.